Each day for the past 4 years, I've motored along this winding stretch of Essex Road to the place where I work. It leads me from my home in Malden to a construction site on the banks of the River Blackwater, near to where the river enters the North Sea. This part of the road used to be the perimeter track of a wartime aerodrome, and those are the site offices. I better introduce myself. My name is Young, Andrew Young. I'm chief resident engineer here. This is my office. Like most other people in my profession, I'm an active man. I've spent the greater part of my life outdoors. They used to call us rough-necked engineers in the old days. They gave us an old wooden hut, a few drawings, and we got on with the job. It's different today. A lot of the work is complex and to very fine tolerances. All this paperwork tends to make a man chairborne. There are construction schedules, minutes of meetings, instructions from headquarters, reports from contractors. A man like me needs a first-rate group of site engineers to back me up, and a good secretary. In 4 years, we've changed the appearance of things down here. You caught a glimpse of what we're building when we drove down the approach road. My daily tour of the site keeps me up to date on progress. Yes, you were quite right. It's a nuclear power station. One of the first 2 to be built in this country. It's called Bradwell. That's the turbine house on the left. The other 2 buildings are the reactors. Each of these reactors will produce sufficient energy to generate 150 megawatts of electrical power. That's 300 megawatts in all, or put another way, 500,000 horsepower. We started building here in January 1957. Our customer is the Central Electricity Generating Board, and they will operate Bradwell as a base load station when it comes into service in 1962. Putting it simply, my job, and that of the other engineers on site, is to interpret correctly the design requirements and to see that all the bits and pieces fit together at the right time, in the right order. Down there is the switch yard. It's from this yard that electricity generated by the station turbo alternators will go out to the national grid. Oh, I suppose it's only human to express some pride in what we've accomplished now that Bradwell nears completion. But I remember not so very long ago, let me see, April 1958, when the view from here looked very different. Then the turbine house was just a skeleton of girders. We hadn't got very far above ground on number 1 reactor. Here, looking from the top of the Goliath crane, you can see the River Blackwater in the background. In front is number 1 reactor. Nearer this way is number 2 reactor, just at ground level from an excavated depth of 40 feet. That's a good view of the shape of the reactor vault. It was in May 1958 that the first of the 12 boilers, there are 6 for each reactor, was due to be launched. Launched? Yes, we launched them, just like a ship. You see, we had a problem with the boilers. They were designed and manufactured at the factory of one of our member companies at Thornaby on the northeast coast. Even as an empty shell, each boiler weighed 200 tons. They were 87 feet long and 19 feet in diameter. With such dimensions and weight, and also distance, road transportation of the boilers would have been a formidable task. So we sealed each boiler in a slightly pressurized state, slid them down a slipway at the factory into the River Tees, and towed them by tug the 300 miles down the North Sea to Bradwell waterside on the Blackwater. At the waterside, we had constructed a twin-armed quay for the reception of the boilers. The arrival of the first boiler attracted large crowds, including some colorful local characters. even the short distance from the quayside onto site had its problems. And we were all relieved when it had been towed safely along the 2 miles of road to its position beneath the Goliath crane on site. Our Goliath was the first of its type to be used in the construction of a nuclear power station. It runs on standard gauge railway tracks and spans each reactor building. During its lifetime on site, it has had to carry 24 major items of reactor equipment, each in the region of 200 tons. Its first job was with number 1 boiler. We had spent 8 months erecting the crane. It was a bolted construction to facilitate dismantling for use on another site after the completion of Bradwell. Now it was being put to the test as an important construction tool. On any large site, there abound many skills. The craft and ingenuity of fitters, welders, electricians, and the many other trades become apparent at an early stage. But people seldom recognize crane drivers. The delicacy and precision with which this giant crane was operated, often with loads made difficult by the rising structure of the reactors, had to be seen to be believed. Well, we got number 1 boiler safely installed at the north end of number 1 reactor. And a lonely sight it looked too. But it started another phase of our work, the steam raising side. Men could now inspect its interior, establish those clinically clean conditions so essential in nuclear engineering, and prepare for tubing up. I'm not a physicist. It's not my responsibility to calculate nuclear performances or heat ratings. I leave all that to our designers. But the construction of the reactor cores and containment vessels falls within my jurisdiction. At the south end of the site, past number 2 reactor and not so very far from my office, is the pressure vessel welding area. It's operated by another of our member companies. Their main task is to construct 2 spherical vessels, each of 66 feet 9 inches mean diameter, made up from hot-pressed and normalized special mild steel plates of 3 inches and 4 inches thickness. The reactor vessel has been designed for a gas temperature of 400 degrees centigrade. These are small plates being unloaded. More than half the welding on site is done with automatic equipment. The individual plates are first made up into rings on jigs and then lifted into position within the reactor vault by the Goliath. All our welders had to pass a Class A standard of workmanship before they could work on the pressure vessels. At the time of construction, the Bradwell vessels were the largest and thickest of their type. Each one weighs more than 1,000 tons. You can see the bottom ring segment being fabricated here. As it will support the weight of the upper rings and also transmit the internal weight of a graphite core to the reactor foundation, the plate is 4 inches thick. Our construction schedule called for number 1 reactor to be completed some few months before number 2. So we pressed on with number 1 vessel first. Here you see number 2 ring nearing completion. By using a Goliath crane, the top of which can clear even the height of a finished reactor building, the civil engineering work was allowed to forge ahead without being halted for the installation of heavy plant. This is the bottom ring again, all 200 tons of it, ready and waiting installation in the reactor vault. We were becoming used to the way in which the Goliath handled such loads, but the crane dimensions overshadow the size of the ring. Whenever